So I actually probably just did simplify. Yeah.
All right, problem 2. So 1 through 4. These are the ones where you can only get a single answer because these problems start with an inverse. When you get to problem 5 on, do those have inverses in them? No. So those are asking every single time it happens, and you will get multiple answers on those. So 1 through 4, the original problem has an inverse. That means I only have one answer. So arc, cotangent, cotangent inverse. What quadrants can cotangent inverse be in?
1 and 2.
1 and 2. In which of those would it be negative?
2.
Okay. Then I'm asking myself, all right, when is cotangent 1? So that would be at 45 degrees. Then 45 in quadrant 2, 180 minus 45,
135.
35. All right, cosecant. If you don't like thinking about cosecant, you can think about sine if you prefer. This means cosecant of y is -3 or sine of y is -1/3. Quadrants. What quadrants can sine or cosecant inverse be in?
1 and 4.
In which of those would it be negative?
1 and 4.
Okay. Do we know when sine is 1/3? No. So that's when we pick up our calculator. We'll do sine inverse of positive 1/3. So that's 19.47 degrees. Then to put that in quadrant 4, you do 360 minus 19.47. And we get 340.53 degrees. What about 1 or 3? Do we need to go over those inverse problems? So problem 6. Probably your first instinct is you want to divide by tangent because it's on both sides. But if you divide the tangent, you will actually lose answers. Instead, we need to bring it over and factor. So we have two terms. They both have a tangent in them, so we'll factor out the tangent. If we take that out, we get secant squared minus 2. So now we can set these equal to 0. If tangent is equal to 0, think about your unit circle. Tangent's y over x, so if that's 0, that means y is 0. So that happens at 0 and pi. This one will be when secant squared is 2, or to get rid of a square, you do a square root. If you add a square root, what else do you need? Well, if you don't like secant, that means cosine is positive or negative. 1 over radical 2 is radical 2 over 2. Positive and negative tells me I'm dealing with every quadrant. Reference angle. When is cosine radical 2 over 2? So pi over 4 in every quadrant. So in quadrant 1, that's pi over 4. That's quadrant 3. Let's do 3 pi over 4 in quadrant 2. And what would it be in quadrant 4? Any questions on that one? Problem 7. So it's equal to 1. I'm going to go ahead and subtract my 1 over. So then this is sine squared, sine constant. It's a slip and slide problem. So you bring your 2 down. So what multiplies to -2 and adds to positive 1. Okay, we start out multiplying the 2, so we have to divide it back. So if we set these to 0, that means sign could be negative 1, or sign could be a positive 1/2. So think about your unit circle. Sign is the y. When y is negative 1, that is 3 pi over 2. In which quadrants is sign positive? Reference angle. When is sign 1/2? 30 degrees. In radians, that's pi over 6. So pi over 6 in quadrant 1 is pi over 6. In quadrant 2, that would be 5 pi over 6. Are we doing better with these? Problem 8 is tricky because I have 2 different trig functions. So I can't just, there's no greatest common factor like we did on problem 6. There's no quadratic formula type problem because we have 2 different functions, so we can't do it like we did problem 7. What else can we do? Pythagorean identity. We know cosine squared plus sine squared is 1. So I can replace my cosine squared with a 1 minus sine squared. So if I subtract over my 1, those cancel. Add over my sine squared, so I get 0 equals 2 sine squared theta. Simply divide by 2. Square root. We just get that sine is 0. So if we think about the unit circle, sine is your y. Y is 0 at 0. And pi. Anything else on the first page? Alright, so if I'm trying to solve this, if I want my cosecants on the same side, I can subtract over this cosecant theta, add over my 1. So cosecant is negative 2. If you don't like thinking about cosecant, do its reciprocal. That means sine is negative 1. Quadrants. When is sine negative? Reference angle. When is sine 1/2? 30 degrees. And we are, oh, we're still in radians, aren't we? Problem 10, which is 2 degrees. So that would be pi over 6. Okay, so pi over 6 in quadrant 3 and in quadrant 4. So what were we doing wrong on this? Were you guys just not giving all the solutions, or were we making algebra errors? What was getting us on this? You weren't doing all the solutions. Does this make sense? So then we got into the ones where we have to look at double and triple solutions. I did flip in 2 degrees for these. So it starts out the same. We get our trig function by itself. Okay, cosine is positive. What quadrants is cosine positive? Reference angle. So you can look at a unit circle. You're welcome to fill one out on the test. Or hand trick, when is cosine radical 3 over 2? 30 degrees. Okay. Because my angle is 3x, that tells me we are going to have triple solutions here. We talked about it in terms of like the graph. We know that 3 shortens the period, so it's going to repeat 3 times. So my angle is 3x. In quadrant 1, 30 degrees is 30 degrees. In quadrant 4, 360 minus 30 is 330. So to get x, we divide by 3. So we get 10 and 110. That's 2 answers. So if I'm going to triple it, I need 6. All the way around the circle is 360. We're going to go around 3 times, so divide by 3, that's 120. So I add 120 to each of these twice. So that would give me a 130 and a 250 for my 10. 110 plus 120 is 230 and 350. Okay, and the reason I had to add on those extra answers is because my angle was 3x. So it shortened my period, it repeated more times. Problem 11, if my angle is x over 2, what will that do to the graph? It's going to make it longer. So by the time I get to 360 degrees, I'm only going to have half my graph. What that means, sometimes it won't change my answers at all. Sometimes I'll have answers that are bigger than 360, and we'll disregard those. Look at problem 11. My cosines on the same side, that's 2 cosine of x over 2. Divide by 2. Okay, quadrants. When is cosine positive? Reference angle. When is cosine radical 2 over 2? So my angle, x over 2, could equal, in quadrant 1, 45 degrees is 45. In quadrant 4, 360 minus 45 is 315. If we're trying to solve for x, what would we have to do now? That gives me 90 and 630. Both of these are answers, but I only asked for the ones between 0 and 360 in my directions. So 90 is the only one that fits that requirement. Okay, not that 360 doesn't work, it's just outside of the interval I was asking about. Problem 12. Okay, what does 2x tell me? If you don't like thinking about cotangent, you're welcome to flip it and think about tangent. But do we know a time when tangent is 5/4? No. Quadrants, when is tangent positive? Reference angle. We don't know, so we're going to go to our calculator. Tangent inverse of 5/4. So that gives us 51. Let's just do 2 decimal places. 0.34 degrees. So that means my angle, 2x, could equal, in quadrant 1, my reference angle is my angle. In quadrant 3, you have to add 180. So then how do we find x? We said double solutions. We have 2, so if I want to double it, I get 4. All the way around the circle is 360. Divided by 2 is 180. So we're going to add 180 to each of these. So that gives us 205.67 and 295.6. And those would be our 4 solutions. Is that okay? as soon as I see a 2x, that tells me what? If you don't like thinking about secant, that's reciprocal of cosine. That means cosine is 1 over the square root of 2 or radical 2 over 2. So when is cosine negative? Reference angle, when cosine is radical 2 over 2, that would be, so my angle, 2x, would equal 45 degrees in quadrant 2. 180 minus 45 is 135. Quadrant 3, 180 plus 45 is 225. Divide them by 2. We get 67.5 and 112.5. But I said double solutions. So we need to get the other two. All the way around is 360. We're going around twice, so divided by 2 is 180. So if I add 180 to each of those, we get 247.5 and 292.5 degrees. Again here, 2 theta tells me so if we're trying to get our signs together, divide by 5. Quadrants, sine is positive 1. Oh, okay. Reference angle. Do we know when sine is 2/5? No. So if we don't know it, we do the inverse. So that's second sine of 2 over 5. And that would be 23.58 degrees. So our angle, 2 theta, could equal, in quadrant 1, the reference angle is the angle. In quadrant 2, you subtract from 180. We're trying to find theta, so if we divide those by 2, we get 11.79 degrees, 78.21 degrees. But we're not done. We said double solutions. We found 2, but if we're going to double it, we need 4. Way around is 360 divided by 2, so we're going around twice, is 180. So add 180, we get 191.79 and 258.21. Alright, so I didn't tell you whether to do law of sines or law of cosines, and it kind of just matters what information you're given. If you're looking at problem 15, you know, I gave you angle A and side A. I gave you angle B and I want side B. So which one did you use on problem 15? Law of sines, because we had 2 angle side pairs. Same thing on number 16, right? I gave you an angle on a side, another angle looking for that matching side. So those are definite law of sines problems. 17 is a little less obvious, and I had a couple people asking if they could do law of cosines here. So I gave you side A, angle A, side B, and I want angle B. The problem is, if you're looking at your law of cosines formulas, the only one that involves angle B, has a cosine of B in it, you have to know side C to do it. Do we have that information? No. So that means even if you try to use law of cosines, you don't have what you need. You have to go back to law of sines. And we're using law of sines basically anytime we have an angle side pair. because I have side, both angle A and side A, so that's a good indicator the law of sines is going to be helpful. So we have information about A and B, so that's the ratio we pick. A over sine A equals B over sine B. So side A, 9.72, over the sine of 38 degrees, 40 minutes, equals side B, 11.8, over sine B. If we cross multiply, then we have to divide the 9.72 over. Alright, so if I put this in, we have 11.8 sine of 38 plus 40 over 60 divided by 9.72. So then what do you have to do?
Sine inverse.
Okay, so if we do that sine inverse, we get 49.33 degrees. But here's the thing. We know sine is positive in both quadrant 1 and quadrant 2. What I just found is B if it's in quadrant 1. What would I have to do to get quadrant 2? And then we always kind of had to figure out if that was reasonable. Now, I didn't ask you to solve for everything. And in fact, I told you in the problem to give me the 2 possible values so you know they're both going to work. When I did have you solve for everything, how did we know one didn't work? Yeah. You would either have, like, the case where there were no triangles, when you went to do sine inverse, it would be something bigger than 1 right here, so it wouldn't work. Or when I found my third angle, it would turn out to be a negative, and we know that wouldn't work. Here, I've already told you they both do work. Those are the answers I'm looking for. Yeah.
So how do you really put on a denominator for this part?
Oh, I was just trying to decide myself. And that's where what we do. Other questions? Yeah.
Not as much as this sounds good. Maybe pretty cool. Now this sounds. I seen horizontal and vertical and I was like,
Alright, other questions there? So then, like, problem 18, is it possible to do law of sines on that one? No, for law of sines to work, you have to have an angle side pair. The only angle I have is the side I don't have, so that's when you're forced to do law of cosines. Alright, and then after that we went into the vectors. We asked about problem 22. So I told you theta is 40 degrees and the magnitude is 17. Okay, all it's asking, the horizontal and vertical components, I'm basically saying write the vector. And the vector is just magnitude times cosine of the angle, magnitude sine of the angle. And that would be on your formula sheet. So our magnitude is 17 cosine of 40 degrees and 17 sine of 40 degrees. So if I plug those in, gives me 2 and 10.93. So I just wanted the vector itself.